Hello guys, good day. We are here again to discuss a new lesson, and that is solving quadratic equation by completing the squares. Hope you enjoy it. So we have to go first with objective number 1, and that is the numerical coefficient of the quadratic term is equivalent to 1. Therefore, we're going to solve for the unknown variable. So considering this kind of problem, we have here x squared plus 6x plus 7 is equal to 0. Try to take note that that 1 is not the same way, is not factorable. So all we have to do is that we have to familiarize on how to get the perfect square trinomial, wherein we have here the x squared plus 6x plus 7 is equal to 0. It will make as quantity x plus 3 quantity squared, and then it is just equal to constant the right side of the equation. So you have to make use of the square root property for us to be able to get the completing the square. But first we are going to familiarize something, or we are going to recall something, the concept of the perfect square trinomial, wherein we have here the x squared plus 2kx plus k squared, or the other one is x squared minus 2kx plus k squared, where k is in the representations of any numbers. Okay, in the first example, we are going to have first how to complete the perfect square trinomial. We have here the first problem, and we have x squared plus 12x plus blank. So what we have here is the constant term. We are going to find out what is the value of the constant term, and we also have the value, another example, which is x squared minus 14x plus the blank. So then again, we're going to solve for the constant term out of this. So the solution for the first problem, which is x squared plus 12x plus the blank, is that, take note that we have here the blank, there is representation for that is the k squared, from the given that we have previously, that we have x squared plus 2kx plus k squared. So therefore, what we have now is k squared. So we have 12x is equal to 2kx. So therefore, we have now the value of the 2kx, which is the 12x, or the linear term. So as we go through for this, since we have common or same variable, so we are going to have the identity of that. So we have now 12 is equal to 2k. Then after which is we're going to find the value of k. So divided both sides by 2. So we have now k is equal to 6, or 6 is equal to k. Then after which, so we have now the k squared as what we have there here, the example, from the example. So we're looking for the k squared. So square of 6 is, we have here 36. So therefore we have as factored form. So from the perfect square trinomial, which is x squared plus 12x plus 36, so we have now as a factor quantity x plus 6 quantity squared. Okay, so let's proceed to the another example, which is x squared minus 14x plus k squared. Still the same, that we're looking for the value of k squared, but take note that the value of 2kx is equal to negative 14x. So as we got through with this, is we have negative 14x is equal to negative 2kx. So therefore the value of k now is, what I mean is that as we go through for this, is we have here negative 14 is equal to negative 2k, because we have here x and we also have here x, so they are both the same, so we are going to cancel it out. So what we have now is this, which is negative 14 is equal to negative 2k. So we are going to divide both sides by negative 2 from the multiplicative inverse of negative 2 for us to be able to get the multiplicative identity for this of the to make it 1 here, or the multiplicative in the identity. So we're going to divide both sides by negative 2. And so we have k now is equal to 7 because negative 14 divided by negative 2 is positive 7. So after which, if we're going to square the 7, because what we wanted now is to get the value of k squared. So square of k is equal to 49. And so we have 49 is equal to kx squared. So the kx squared now here from the given equation, from the given expression rather, take note again, expression and equation is not the same. So from the given example, this is just only the expression because we don't have an equal sign here. So 49 is equal to kx squared. So as a factored form for this, so we have, what do you think? Yes, the factored form for this is quantity x minus 7, quantity squared. Why is it minus 7? Because the middle term of the given is negative 14x, or the linear term for that is negative 14x. So that is why, as we factor it out, we have x minus 7, or the square of x minus 7. Okay? So we are now done with the previous example. So let's proceed to what we have done, what we have a while ago, and that is x squared plus 6x plus 7 is equal to 0. And it makes it a quantity x plus 3 quantity squared is equal to 0, or equal to 2 rather. So through the use of the completing the square, so we have now changed everything. Take note that we are recalling ourselves already how to work with a perfect square. So we have from the given x squared plus 6x plus 7 is equal to 0. First thing that we should do is the constant term, which is positive 7, transpose it on the other side of the equation to make it x squared plus 6x is equal to negative 7, because both sides be added by negative 7 for us to be able to work with, to make it 0, the positive 7 on the left side of the equation. So we have to add both sides of the equation by negative 7. So from here, so since we have x squared plus 6x, we are going to make it that one as a perfect square trinomial. So we have, on the other hand, for us to solve with this, the half of the numerical of the linear term, which is 6, from 6, half of it is 3. So the square of 3 is 9. So therefore, we have now add both sides by 9. Again, the half of 6, the numerical of the linear term. Then after that is we're going to square the quotient. So 6 divided by 2 is 3. Then the square of 3 is 9. So from that, add both sides by 9. So we have now on the left side of the equation, we have now an expression of x squared plus 6x plus 9, which is the perfect square trinomial. And the other side is negative 7 plus 9. So the negative 7 plus 9 is equivalent to 2. So we have now the factor of x squared plus 6x plus 3, which since it is now a perfect square trinomial, so we have now quantity x plus 3 quantity squared. Then the sum of the right side of the equation is 2, because negative 7 plus 9 is 2. So that is why from the process of getting quantity x plus 3 quantity squared is equal to 2 is this. From the given x squared plus 6x plus 7 is equal to 0. So take note that when we work with the completing the square, it is not only here how to solve for the unknown valued x or unknown value for the quadratic equation, but of course, as we go through for this, is we're going to find it out the use of how to get the circle, the equation of the circle, the standard form of the circle, then after that its center. So there is a continuity of how to work with the completing the square. So we are going to familiarize how to get the completing the square. Okay? Take note with that. So we have here another set of example, rewriting an equation to use the square root property or the square root property. So from the given x squared minus 20x plus 34 is equal to 0. So take note that we're going to solve for the value of x. So through the use of the completing the square, so the solution for this is we have to, since we have now the constant which is plus 34, so make it 0 for that, so we have to find it out. We have to add both sides by negative 34, so that is why negative 34 on the right side became negative 34 on the right side, because 0 plus negative 34 is negative 34. So what is remaining on the left side of the equation is we have x squared minus 20x. So from that, from this binomial term, we are going to find out how to complete this one to make it perfect square trinomial. So negative 20x, take note that we have here the linear term which is negative 20x. Half of negative 20 is negative 10. And the square of negative 10 is 100. So that is why it became that. Okay. So we have k is equal to 10, and the square of 10 is 100. So from here, we're going to add both sides by 100. So we have now a perfect square trinomial of the left side of the equation. We have x squared minus 20x plus 100 is equal to negative 34 plus 100. So to go over with the next step or the next process, so the factor of the left side of the equation is quantity x minus 10 quantity squared is equal to 66, because negative 34 plus 100 is 66. And since the linear term that we have from the quadratic equation is negative, so that is why x minus 10 as the factor of the perfect square trinomial given. So we have now to get the value of x. So from the extracting square root, so we have now quantity, the square root of quantity x minus 10 quantity squared is equal to plus minus square root of 66. Since the 66 then cannot be simplified, so we have to leave as is the plus minus square root of 66. So we have now break that one. So we have the first one is x minus 10 is equal to positive square root of positive square root of 66, and the other side is x minus 10 is equal to negative 66 square root of 66. To solve for x of the first one is we have to make this negative 10 to make it 0, so we have to add both sides by 10. So we have now x is equal to 10 plus 6 plus square root of 66. On the other side is also we have x is equal to 10 minus square root of 66. Take note that even if we can factor the 66 by 6 times 11, as far as the square root is concerned, to make it simplified, it must be one of the factors should be perfect square. So since 6 and 11 is not perfect square, so we have to leave as is the square root. So we leave as is as the square root of 66. So therefore the value now of x is equal to the set 10 plus minus square root of 66. So let's proceed to the example number 3. So the example number 3 is we're going to solve for x squared plus 4x is equal to 1. Take note that we could not work with the factoring regarding this case. So that is why the completing of squares or completing the square takes in. So the solution for this is we have x squared plus 4x is equal to 1. Then from the given x squared plus 4x. So we have to make that one as a perfect square trinomial. So we have 4x as the linear term. Its numerical coefficient is 4. Divide both sides by divide 2. Then after that, you have to square the quotient. So the quotient is 2. Then the square of 2 is 4. So that's why we're just adding both sides by 4. So we have now x squared plus 4x plus 4 is equal to 1 plus 4. From this is we have quantity x plus 2 quantity squared is equal to 5, because the factor of x squared plus 4x plus 4, since that this one is a perfect square trinomial anymore, so we have this, the square of x plus 2. Then the sum of 1 plus 4 is 5. Then after which is for us to be able to get the value of x, so we have to extract both sides by the square root. So therefore we have take the square root both sides. So the square root of x, quantity x plus 2 quantity squared is equal to plus minus square root of 5. Then after that is we have x plus 2. Since on the left side of the equation, this is a perfect square, so the square root of a perfect square is what is the base that we have. So the base that we have is x plus 2, so that is why x plus 2 is the value of the square root of the square of a certain number. Then the other side is we have plus minus the square root of 5. To solve for x is we have to make this plus 2 a 0. So add both sides by negative 2. So that is why negative 2 plus square root of 5. So based on the answer that we have, or the process, it is already separated the plus minus. So that is why the first x is equal to negative 2 plus the square root of 5. On the other hand is we have x is equal to negative 2 minus square root of 5. So therefore, the value of x is equal to the set negative 2 plus minus square root of 5.